In this video today, instead of me teaching you new topics, what I'd like to do is present you with some previous exam questions or specimen questions and give you a chance to have an attempt at them, and then I'll go through the answers. So the way that I would approach this video is I will show you a question, I'd pause the video, give that question a go, then come back and see my solution, okay? So the first first question's here, worth 6 marks in total. If you pause the video now, and then I'll go through the answer when you get back. Right, so the first question, AI, hopefully you've seen is because it involves a log and an x to the half, it is a product rule question. So u is x to the half, u dash, you multiply by the power, lower the power by 1 as per usual. So that's our u and this one as our v. So if that's log of 3x, v dash, if you remember, is the function on the bottom, the differential of the function on the top, so that cancels down to 1 over x. I mentioned in one of the previous videos that if you have log of any number of x, it's always equal to 1 over x. So if we then put that into u dash v plus u v dash, that would get us that we have a half x to the minus a half log 3x plus u v dash x to the half times 1 over x. You could simplify that slightly. So I would probably write this as log 3x over 2 root x, or 2x to the half. And this one here, x to the half divided by x would be x to the half, take away 1, so x to the minus a half. So you could also write that as 1 over root x. Okay, if we carry on to the second part, this hopefully you saw was a quotient rule question. So u in this would be 1 minus 10x and v would be 2x minus 1 to the 5. So u dash is minus 10 if you differentiate that. V dash, you would have to follow the chain rule. So you multiply by the power, lower the power by 1, and multiply by the differential of the bracket. So that's 2. So v dash is actually 10, 2x minus 1 to the 4. So then if we put that into the quotient rule, that would give us that we have, well, if you use u dash v minus uv dash over v squared, that would give us minus 10 multiplied by 2x minus 1 to the 5, take 1 minus 10x multiplied by 10 lots of 2x minus 1 to the 4, all over v squared, which would be 2x minus 1 to the 10. So that can be simplified, and in this situation it does say that we want it in its simplest form. So what I would do here is I would say, well, if you look at this, we actually have 2x minus 1 to the 10 there, to the 5 there, and to the 4 there. So we could actually cancel out 2x minus 1 to the 4. So that will give us minus 10 lots of 2x minus 1. Take away 1 minus 10x times by just 10 over 2x minus 1 to the 6. So we have minus 20x from there, add 100x because it's minus 10x times 10. So 20x adds 100x is 80x. Minus 10 times minus 1 is plus 10. Take away 1 times 10, so take away 10 is nothing. So you have 80x over 2x minus 1 to the power of 6. So that's the first question. Okay, I'll give you your next question. So This one, again, another differentiation question. So if you pause the video here, give it a try, and then I'll go through it. Right, so if you're wanting to find the gradient of anything, you always have to differentiate. So if we differentiate this, that would give us that log y differentiates to 1 over y. But anytime you have, if you're differentiating a y with respect to x, you have to multiply by dy by dx. This is a product rule because it's 2x and log x, which will differentiate to 2 and 1 over x. So u dash v, 2 log x, plus u v dash, 2x times by 1 over x is just 2. So dy by dx would be y lots of this. So what you're going to also have to do here is, if we are using that x is 2, we need to find out what y is. So log y will be 2 lots of 2 log 2. So log y would be 4 log 2. So this is bringing back some of the log laws that you've learnt previously. So if we had log something equals log something else, y would just equal that number. So if we can put it in that form using one of the log laws, such as this one. So if you have something in front of your log, you can bring it into the side of the log as a power. So log y equals log 2 to the 4. So y is 2 to the 4, which is 16. So that means that if we go back to our gradient, dy by dx is 16 lots of 2 log, or x is 2, plus 2, or 32 log 2 add 2. So that would be acceptable as an exact value. There's other variants you can have on that, but that would be the most sensible. Okay. Get the next question. Okay, so the third question is another implicit differentiation question. You can tell that's because of the y's and x's being involved. So if you pause the video again, give this a try, and then come back and listen to the solution. Right, so anytime you're trying to find the gradient, we've mentioned this before, you have to differentiate the equation. So there's a few things needed here. Normal differentiation will take that to be a 2. Implicit differentiation, you differentiate the 3y squared to get 6y, but you have to multiply by dy by dx. The 3x squared y will be a product rule question. Now, I'm going to, on this one, not write out the full steps, but just talk you through the product rule. So if we take u being 3x squared, if we differentiate that first, we will get 6x lots of y. If we differentiate the y instead, you would have 3x squared multiplied by dy by dx. And that equals the differential of that, which would be 8x. So to get your gradient, we're going to have to get the dy by dx by itself. So dy by dx, well, 6y dy by dx, add 3x squared dy by dx would equal 8x minus 6xy and minus 2. Or dy by dx, lots of 6y add 3x squared is 8x minus 6xy minus 2. If we then divide through by the bracket, we have 8x minus 6xy minus 2 over 6y add 3x squared. So that would be our gradient equation. If you look back at the question, I'll just write the coordinates here. It says the point P has the coordinates minus 1, 1. So substituting in those values, you get 8 lots of minus 1, take 6 lots of minus 1 times 1, take 2, over 6 lots of 1, add 3 lots of minus 1 squared. So minus 8, add 6, gets you minus 2, take 2 is minus 4. 6, add 3, gets you 9, so the gradient is minus 4/9. So then part B said, hence find the equation of the normal to C at P, giving your answer in the form ax plus by plus c equals 0. So this is following the same things you've been doing since early A level. We find the normal gradient, which will be the negative reciprocal of the previous gradient. So it would be positive 9 over 4. Then we can do y minus y1 equals mx minus x1. So y take away 1. If you remember, the coordinate was minus 1, 1. So y take away 1 equals 9 over 4 x take away minus 1. So y minus 1 equals 9 over 4x plus 9 over 4. Because take away minus 1 is plus 1 times 9/4. So then if we need to get it in the form ax plus by plus c equals 0, I would probably take the y over and the minus 1. So 9/4 of x, take y. 9/4 add 1 would add another 4/4, so it's 13/4. And then if we multiply through by the 4, you get 9x minus 4y, add 13 is equal to 0. Right, save the trickiest one for last. So, we're given a graph that looks like that. We're also given the equation of the graph, which is g of x equals x squared 1 minus x e to the minus 2x. And that is meant to say that x is greater than 0. I don't know why it's come out like that on my printer. So show that g dash of x, so the differential of g, is equal to some function multiplied by e to the minus 2x. And that function should be a cubic. So that's the first part. Second part is to find the range of g. Okay? So take a few minutes to try that question and pause the video, then come back and look at the solution. Right, so for all intents and purposes, at this point, I do not need that graph. We will refer to that in a little while, but for now, we do not need the graph. So if I look at the function g of x, it is possible to do the product rule using 3 parts, but the only way that works is if you do 2 product rules. You say, for example, treat u as x squared 1 minus x, do a product rule on that version, and v as e to the minus 2x, and then combine it all together. But there's a lot easier way of doing it. So if we expand the 1 minus x with this, if we multiply it all by 1, you've got x squared e to the minus 2x times 1. So that's x squared e to the minus 2x. And if we multiply it all by minus x minus x times x squared is minus x cubed times by e to the minus 2x. So then, it's entirely up to you at this point. You could, if you wanted, say, well, let's do a product rule on this and a product rule on this. I'm going to go for that way, but what you could have also done is you could have factorised out e to the minus 2x and had e to the minus 2x as one part and x squared minus x cubed as another. There's many ways of doing it. But let's differentiate this. So I'm not writing out the full product rule, but if we differentiate x squared, we get 2x, e to the minus 2x. And if we differentiate the e to the minus 2x, you just get minus 2 e to the minus 2x multiplied by the x squared. So that is differentiating the first term. If we differentiate the second term, so firstly, let's take the differential of the x cubed to get minus 3x squared e to the minus 2x. And we could also, but the other option is if we differentiate e to the minus 2x, which would get us minus x cubed minus 2 e to the minus 2x. If you're unsure about the way I've done that, the best plan would be to write out the full steps where u is this, v is this, etc. So altogether, we have, if I write this out in a slightly neater form, we have 2x e to the minus 2x, we have minus 2x squared e to the minus 2x, minus 3x squared e to the minus 2x, plus 2x cubed e to the minus 2x. If you factorise out the e to the minus 2x, you would have 2 minus 5x squared from those two terms plus 2x cubed. So when it said back in the question that we have a cubic function to be found, our cubic function would be 2x minus 5x squared plus 2x cubed, which is a cubic function because the highest power is a cube. Hence, find the range of g. So the range essentially is the y values you can get in the function. So we want the highest y value and the lowest y value, and the range would be an inequality that says f of x can be anywhere between these 2 points. This is kind of where the graph comes back in. So we need to find out this point here and this point here and what their y coordinates are. So if that's b and that's a, our answer is going to be that f of x is greater than or equal to that lowest point and less than or equal to the highest point. But we need to find those 2 points. So the way that we do that is we want to find out a maximum and a minimum point. Turning points is where we have dy by dx equal to 0. Or in this case, g dash of x equal to 0. So 0 equals e to the minus 2x, 2x minus 5x squared plus 2x cubed. So either e to the minus 2x is 0, or 2x minus 5x squared and 2x cubed equals 0. Now, hopefully you can remember, but this can never be true. So e to the minus 2x can never equal 0. Now, this is not an e to the minus 2x graph. This would be e to the x. But if you look, the y coordinate is never equal to 0. It should keep going down. It should have an asymptote at y equals 0. The same thing would be true of e to the minus 2x. It wouldn't be exactly this, but it would be approximately this shape here. So there would be an asymptote and it would never reach 0. So that solution, that does not have any solutions. So we just need to solve this bit. 2x minus 5x squared plus 2x cubed equals 0. So to try and solve this, I would factorise out x and say 2x squared minus x plus 2 equals 0. Now, that means that x is 0 is an option, but again, back in the question, x had to be greater than 0. So that cannot also be true. So we can forget that one. So we only actually have to look at 2x squared minus 5x add 2 equals 0 to get our solutions. Let's get some more paper. So 2x squared minus 5x add 2 equals 0. I would say the easiest way to go about this would be completing the square. So factorise and you get 2 lots of x squared minus 5 over 2x plus 2 equals 0, or 2 lots of x minus 5 over 4 squared, take 25 over 16, plus 2 is 0. So x minus 5 over 4 squared, take 25 over 8, add 2. 25/8 add 2 would be, you'd have to add 16/8, so minus 25 add 16 will get you minus 9. So x minus 5 over 4 squared, 2 lots of x minus 5 over 4 squared equals 9/8. That equals 9/16. Now, it looked all the way through that it was going to be horrific numbers, but hopefully you can see that that is a square number. So if you square root both sides, you have plus or minus 3/4. So if we do 5/4 plus or minus 3/4, you have two options. Minus 3/4 add 5/4 would be positive 1/2, and positive 5/4 add 3/4 would be 8/4, which is 2. So going back to our original graph, if I can find it, there we go. The largest, this coordinate here is when x is 2. This coordinate here is when x is 1/2, this is where x is 2. So if, nearly there. So if x is 2, y is 2 squared, 1 minus 2 e to the minus 2 lots of 2. So 4 minus 1 e to the minus 4. So minus 4 e to the minus 4 when x is 2. If x is equal to 1/2, then y is equal to 1/2 squared, 1 minus 1/2, e to minus 2 lots of 1/2. So you have y equals 1/4 times 1/2 e to the minus 1. So 1/8 of e to the minus 1. So that gives us our range. So the lowest value is this negative number here, minus 4e to the minus 4. It's less than or equal to f of x, which is less than or equal to e to the minus 1/8. So that question is very intimidating in terms of its algebra, but it's just following the same rules you've done before. You just talk about maximum minimum points being when you have a gradient of 0 and persevere with the algebra. There'll be a second video like this in a couple of days where I do a few more of these questions on differentiation. Hope you found this useful.